Hello, I'm Raj Shekhar, and welcome to the Open Book, where we question the beliefs we rarely examine and the choices shaping our world. Nothing is off the table. Some questions may unsettle you. Some answers may challenge you. Because the future is being written right now, and we are holding the pens. In the last block, we confronted a troubling number, 8 billion people on Earth. But the real question is not how many of us are here. The real question is what those billions of humans are doing to the planet itself. Welcome to the Anthropocene, when humans became a geological force, the third blog in the Inheritance series. This series is about legacy, not the legacy of wealth, titles, or awards, but the deeper inheritance we leave behind, the planet itself, and the world future generations will receive from us. Let us begin with a thought experiment. Imagine a group of geologists living 10 million years in the future. They are digging through layers of rock, reading the long story of Earth. They see the familiar signs of the past, layers left by ancient oceans, traces of ice ages, the thin scar left by a massive asteroid that wiped out the dinosaurs. And then they reach a strange layer. It is thin but unmistakable. Inside it they find fragments of plastic embedded in rock. They find radioactive particles scattered across continents. They find aluminium alloys that do not exist in nature. They find the fossilized bones of billions of domesticated chickens. And they see a sudden disappearance of thousands of species. To those future geologists, the conclusion will be obvious. Something extraordinary happened here. At some point in Earth's long history, a single species became powerful enough to reshape the entire planet. That species was humans, us. Something extraordinary has happened in the last century. Something that has never happened before in the planet's 4.5 billion year history. For most of Earth's existence, the planet was shaped by forces beyond imagination. Continents collided and tore apart. Ice sheets buried entire hemispheres. Volcanoes darkened the sky for decades. Asteroids ended the reign of dinosaurs. These were the great geological actors that shaped the planet. But sometime in the last 100 years, another force appeared. Not from the depths of the mantle. Not from outer space. But from cities, factories, farms, machines, human civilization. In just a few generations, human activity began altering the atmosphere's chemistry, ocean temperatures, river flows, soil composition, and the diversity of life across the planet. Our industries changed the air. Our farms reshape entire continents. Our cities spread across landscapes once dominated by forests and wetlands. Our waste now reaches the deepest trenches of the ocean. For the first time in Earth's long history, one species became powerful enough to reshape the planet itself. Scientists have given this moment a name. They call it the Anthropocene, the age of humans. The word Anthropocene began circulating around the year 2000, when the Nobel Prize-winning atmospheric chemist Paul Crutzen and ecologist Eugene Sturmer proposed that human activity had become powerful enough to leave a permanent mark on the planet's geological record. Think about what that means. For millions of years, geological layers were shaped by natural forces, volcanic eruptions, asteroid impacts, and slow movements of tectonic plates. Human civilization is now leaving traces of strange new materials that never existed before: plastics, synthetic chemicals, aluminium alloys, and concrete. Scientists have even coined a new word for them. They call them technofossils. Interestingly, the idea of the Anthropocene is still debated among geologists. But the deeper reality remains clear. Whether or not the Anthropocene becomes an official geological term, human activity has already become the dominant force shaping the Earth system. Humanity has moved from being a species, a part of nature, to becoming a planetary power. But when did this transformation really begin? Human influence on ecosystems started thousands of years ago. But the real turning point arrived with the Industrial Revolution. Steam engines, coal-powered factories, oil-driven transportation. Suddenly, human civilization gained access to enormous quantities of energy stored in fossil fuels. Energy meant power. Power meant scale. Cities expanded. Industries exploded. Global trade intensified. And then something remarkable happened around the middle of the 20th century. The pace of change accelerated dramatically. Scientists call this moment the Great Acceleration. Research by Earth system scientist Will Stephan and his colleagues shows that after about 1950, nearly every indicator of human activity began rising sharply at the same time. Population growth, industrial production, energy consumption, fertilizer use, transportation networks, global trade. Everything surged upward. And at exactly the same time, indicators of planetary change also began rising. Carbon dioxide levels increased. Oceans acidified. Forests disappeared. Species began vanishing. Human civilization and Earth systems had become tightly intertwined. Each year, human activity moves more rock and soil than all the world's rivers combined. Human carbon emissions exceed those produced by all volcanoes on Earth. And in 2020, scientists reported a remarkable milestone. For the first time in history, the mass of human-made materials, buildings, roads, machines and infrastructure, had surpassed the total mass of all living biomass on the planet. Think about that. The weight of human civilization now exceeds the weight of all living things on Earth. This is not merely environmental change, but a geological transformation. To understand the full implications of this shift, let us look at how the Earth works. The Earth is not simply a collection of landscapes. It is a vast, interconnected system. Climate, oceans, soils, forests and living organisms interact continuously in a delicate balance. For nearly 12,000 years, during the Holocene geological period, this system remained relatively stable. That stability allowed human civilization to flourish. But in the Anthropocene, that stability is now under tremendous pressure. In 2009, a group of scientists led by Johan Rockström introduced an influential concept called planetary boundaries. Their research identified 9 key processes that regulate the stability of the Earth system. These include climate change, biodiversity loss, freshwater use, ocean acidification, land system change, and the nitrogen and phosphorus cycles. Together, these systems define what the researchers call a safe operating space for humanity. If human activity pushes too many of these systems beyond their limits, the planet could shift into a new and unpredictable state. And today, several of these boundaries are already under severe pressure. The Earth system itself may be approaching critical thresholds. Among all these signals, one stands out most clearly. Climate change. Atmospheric carbon dioxide levels have now surpassed 420 parts per million, the highest concentration in at least 3 million years. Global temperatures have already risen by about 1.1 degrees Celsius since the beginning of the industrial era. The consequences are becoming increasingly visible. The Intergovernmental Panel on Climate Change, the IPCC, has reached a clear conclusion. Human influence on the climate system is now absolutely clear. The warming of the planet is largely due to human activity. At the same time, life on Earth is undergoing another dramatic shift. Species are disappearing 100 to 1,000 times faster than natural extinction rates. Scientists increasingly describe this as the sixth mass extinction in Earth's history. The previous 5 were caused by natural catastrophes, asteroid impacts or massive volcanic eruptions. This one is different. This extinction event is largely driven by human activities that are reshaping ecosystems across the planet. Life on Earth is changing faster than at any point in recorded human history. All of this raises a profound question. What does it mean to live in the Anthropocene? For centuries, humans believed the Earth was vast, resilient and essentially limitless. Nature seemed too large to be altered by human activity. The Anthropocene challenges that assumption. Human civilization now operates at a scale capable of changing the planet's systems and balance. So, now, an energy policy is a planetary policy. Economic growth is a planetary policy. Technology is a planetary policy. If current trends continue, the coming century could bring profound planetary change. Scientific projections suggest global warming of 2.5 to 4 degrees Celsius by the end of this century. Sea levels may rise by nearly a meter. Billions of people may face water scarcity. Coral reefs may largely disappear. Extreme weather events could intensify. Climate-driven migration may reshape global politics. Whether we recognize it or not, humanity has become the steward of Earth's systems. Scientists warn about tipping points, the thresholds beyond which planetary systems change irreversibly. Once certain tipping points are crossed, the planet could shift into a new state that lasts for centuries or even millennia. Which brings us to the central dilemma of the Anthropocene. For most of human history, the question was simple: how can we dominate nature? The Anthropocene forces a different question: how can we live within the limits of a living planet? Because Earth is no longer just the stage on which human history unfolds. We are no longer passengers here. We have become one of the planet's most powerful forces. And that changes everything. For the first time in history, the fate of the Earth is intertwined with the decisions of a single civilization. But that realization leads to an even more unsettling question. If human activity now shapes the entire planet, how much pressure can the Earth actually take? Are there limits, ecological, geological, biological, to what this planet can sustain? And if such limits exist, how close are we to them? We may be approaching one of the most dangerous thresholds in Earth's history. Which leaves us with a question we can no longer avoid. Are we now powerful enough to destroy our planet and our lives with it? If so, what could stop us? That is the question we confront in the next blog. Thank you for joining me on the Open Book. You can read the full blog for more details and references. And I will see you again every Thursday, with another question we cannot avoid. Until then, take care, and think about the world we are leaving behind.